Welcome back. This is Signal Systems and Transform Part 2, Chapter 6.1, Subsection 4. In this subsection, we'll talk about DTFS from a linear algebra perspective. Let's first recap the DTFS analysis and synthesis equation. Here, x of n is a periodic signal, so we put a little curly thing on top of x to denote that it is periodic with n sample. And the analysis equations states that to get ck, where k equals to 0 to n minus 1, can be calculated from this equation. Then we use ck over on the right hand side to reconstruct x of n, showing that this is the time representation x of n, and ck's are the frequency representations. We want to view this in the linear algebra perspective. So ck goes from 0 to n minus 1. We can write it as such: c0, c1 until cn minus 1. C is now a vector of n elements. And on the right hand side, we can also write x as a column vector, x0, x1 until x of n minus 1. There is a relationship from x to c, and this is the relationship. In fact, this equation over here on the top, this equation calculates ck from k equals to 0 to n minus 1. This can be expanded into a matrix that 1 over n remains as 1 over n here, and each of these ck's is calculated through this matrix vector multiplication W. Later you will realize that W is a square transformation matrix. It has a special name. It's called DTFT matrix. Let us see the notation first. N is a column vector of n by 1. 1 over n is a scalar. W is a square matrix of n by n. And x is a column vector of n by 1. So altogether we have n by n by 1 will get n by 1. So the size matches. W is a DTFT matrix, and it is a square matrix because it's n by n. In addition, it is invertible. Now, since we now see this as a vector, a matrix vector multiplication, we can actually find x. And how do we find x? If W bar is the inverse of 1 over n W, then we can find x. So what we did was simply we say that we introduce W bar times C is equals to W bar times 1 over n times W times x. So all we are doing is that we introduce W bar on the left hand side of C, therefore we must introduce W bar on the left hand side of this expression here. And then we say that if W bar is the inverse of this guy, then all we are doing is I times x. And therefore, what is I? Which is the identity element, which is x. And therefore, now we construct x from W bar times C. And this actually is therefore the synthesis equation. And what are the elements of W bar? You'll realize that actually this already reveals the elements of the synthesis equation. C is this C, and therefore W is extracted from all these elements here. In the next slide, I will show you the elements or the columns of W bar. Thank you.